Good evening.
مساء الخير مهندس محمد، اهلا وسهلا.
هلا يزيد، كيفك؟
حياك الله، كيف
Very
حالك؟
good
طيب.
evening.
How are you?
I think
إيه يزيد، احنا جاهزين من طرفنا، لو ممكن نبدأ
واحنا جاهزين
السيشن.
والتسجيل شغال.
Okay, Tiba, you can start the training.
sure. Sure.
Thank you.
Yeah, recording has already started. Okay. So yeah, welcome again to everyone on the day 4 of API management session. So till yesterday, we covered most of the policies. We focused on the routing policies. We tested different routing policies such as dynamic routing, condition-based and context-based routing, and of course the straight-through routing. At the same time, we saw when we are sending the request to an endpoint which has some authentication enabled, we can add either a transport layer authentication or a message layer authentication if the need be. Also, I tried to demo you a few special routing use cases where we can send a REST over GMS or a SOAP over GMS. So the requirement is API gateway, and whoever is the service provider, the native, has to be connected via a same GMS. And then there can be a common topic to which API gateway can publish and the native can subscribe. Native can process the request, give the response back to another reply to topic from where API gateway can subscribe the message and send it back to the consumer. Like the outbound, using GMS over SOAP or SOAP or REST over JMS. We can also enable an API to receive a message from a JMS topic or a queue by implementing enable JMS AMQP policy action at the transport state. And when we are doing adding this policy action, I can still use the same API to be invoked by a SOAP or a REST protocol. We tried to also, I tried to explain the request and response processing policies yesterday. Like several options are available at the request and response process policy stages, whereby we can do message enrichment transformation. We can do some API specification API specification validation. And also we can call some custom extension to call flow service, web methods flow service to do more such message transform, to run more message transformation logic, etc. Now, while we were discussing these two policies, request and response policies, we talked about data masking. And yesterday, I could not properly demo it to you all, like how the data masking is working. And also, I think there was a question to see whether data masking can be applied to both request and response and how it is working. So I will start with that first. And also yesterday, the conditional error processing demo was pending. So we'll quickly complete those two before moving on to today's other topics that are reserved for today. So for data masking, I chose this REST version of it, but the same logic, as I said, can be applied to the SOAP version. The only thing is, instead of for REST API, since request and response structures are following JSON syntax, so we have to use JSON path expression to identify what is the sensitive field and what is to be masked, either whether the field is to be masked or filtered out. And the condition has to be applied only for transaction logging stage or also for payload stage. So my Hello API is sending both mobile number and the name, and I have applied masking logic at the only for mobile number field. So this is the request processing action, and before that, let me turn on store. So this is the log invocation policy that I have configured globally for all APIs, and I am now going to save the request and response headers and payload for all incoming for all API invocations. So let me go back to Hello World. And so I have configured this policy at the request processing stage, which masks out or using JSON path. I'm selecting mobile number and I have selected mask value by a specified string. And additionally, I have selected these option, apply for transaction logging equal to true and apply for payload equal to false. I am going to use this mobile number in my backend system for doing some verification, validation logic for doing some verification and validation. Hence, I cannot filter it out from or mask it in the request. But when this request is logged as part of transaction logging, at least this field will be seen masked. Similarly, I have added the same masking logic for mobile number, and also this message also I'm masking in some cases. Sorry, let me change it. Because message contains mobile number as well. And if I have an error at the error processing stage also, I'm masking this value entirely. So let me call this API first. So mobile number, let me check this. So this API is returning a good response. So the field mobile number is appearing in the payload of the response body that is going to the consumer. Now, if I go to analytics and if I view this, yeah, so I can expand this from this analytics page. I can see the transaction detail. And if I click on view event with payload, it will show the just a second, please. So the masking logic is working correctly, and it is just hiding the mobile number from the request that is going to native. Also, it is hiding like this is the request payload that has come to API gateway, and this is the request payload that has been forwarded to my backend service. Similarly, in the response, actually the whole of the response I think got masked. But if I remove that logic, I will be able to see that the native response as well as native native services response and the uh, API response are both hiding this field properly. So this is how I think this is, yeah, request payload, native response payload. Yeah, both are being masked entirely. But if configured correctly, I can just hide the mobile number, and I think the change did not get successfully saved. So basically, we will see that from everywhere it has got hidden. So request, as you saw, uh, and the response. I think again I have messed up something, but yeah, you got the idea that this is how we can apply masking logic. And also, if there are any, in case of an error, we can implement the same masking logic. So this is now returning an error. So if I view the transaction log now, I'll see in the error event that got logged with payload, there also this if I'm storing the payload correctly, in that case also the this will be applied. So this is how we can implement this in various stages of request response processing and error processing. Also yesterday, like I was talking about conditional error processing. So what I have done is, so my backend service is returning two kinds of error, or rather custom code, when there is a missing mobile number, or in case the mobile number is incorrect, that is, all 10 digits are not correct, not present. And in both cases, my backend service is returning 500 response code. So what I have done, I have applied a conditional I have applied a conditional error processing logic here, which will say like if response code is equal to 500, then I'll do a status transformation to say to set HTTP response code as 400 and request or message as a bad request. And also I can do a variable. I'm defining two custom variables here to say one is error type equal to data error and error description that is coming from the native service. So whatever native service is returning, the same thing I am adding here. So basically the message will have the actual error description using some native service code and status code and process status message. So I'm taking that entire message body and setting it as error description. And in the next stage, I am defining a failure message. So failure message will say, since it is a JSON, we are working with JSON, so I have formatted the failure message in this way. That will say exception, the API service will get substituted by the actual API name, and error type and a description will be replaced by the value from the value of the variable error type and error description that I have created before. So if I now call this, if I now create an exception scenario, you will see that instead of the previous error that API gateway has experienced an error, now this this conditional error is being returned. So it says that data error, status code, status message equal to incorrect mobile number. And this is like the native service error. If I omit the mobile number from here, it changes to it changes to a different description. I mean, the description changes to a different value. If I entirely drop this conditional error processing from here now, from this policy action, now what will happen is there is nothing to format the request, the error. So the consumer will get back a 500 internal server error, which is coming from the native service, and API gateway will return a message and message like this. In case there is like an incorrect mobile number, API gateway will just return this status, and the message will go back to the consumer like this. Although they will all result into error events in API gateway, but still the way I have defined my native service to return an error message in case of a data or a validation error, depending on that, API gateway will just take the response as is and will send it back to the consumer. But with the help of this error conditional action processing, policy action, we can reformat it and give it some meaningful name. So that's all about error handling policies, and also like data masking can be applied in this state also. So yesterday we could not cover this topic. Rather, I forgot to talk about this topic, this policy topic. So this policy is called traffic monitoring policy. So one use of traffic monitoring is to do log invocation, and hence we can configure whether or not to store payload body, whether or not to store the request header. And if we are storing the payload body, we can always select compress the payload data. That will reduce the encrypt and compress and encrypt the, rather not encrypt, it will just compress the request response payload and while storing it in Elasticsearch. So that way we can save some storage of Elasticsearch. Now we can create this log invocation policy locally at an API level, or can globally, so that a standard logging policy can be applied to all APIs. Now, apart from these, apart from this log invocation policy, we have couple of other policies present here. This policy for service result caching is like when we are calling an endpoint, we can add some we can basically cache the response. Now, for caching the response, the response that will be returned by the native endpoint. So for caching that response, we can define several criteria. One can be like based on some header value. Based on some header value, or can be based on some query parameters. So if like the request comes with certain query parameters over and over again, in that case, I can, instead of calling the native, I can look into the cache to get the result and use that to send it back to the consumer. So like any caching caching use case, we have to also define what is the time to live value for this result. So maybe every 4 hours, I will keep resetting the cache so that I can get a fresh result from the backend and can cache the value and then start using it. And also like what kind of or what is the optimum size of the response payload that I can cache. So if the response payload, for obvious reasons, if the response payload is really small, that can be a good candidate for caching. If the response payload is going to be very big, like a few hundred KBs or so, in that case, we should not cache these kind of responses, because anything we cache that will go and sit. I mean, if we are not using Terracotta for caching or clustering, then anything that we create and store it in cache will consume API gateway or the underlying integration server's memory and CPU. So we need to be cautious, and also like we can never be sure what is a good candidate for caching. Maybe a service or a backend service which is returning always some static values can be considered for caching. So I have not seen much use of the service result caching, but maybe if we are to um, cache some static responses, then yeah, we can use this policy action. The useful policy actions here is traffic.
Before moving
Yeah.
from cache policy, the Terracotta or big memory cache configuration. Is there any place in this policy to detect if to set this is the should be saved in the integration, or it is a general configure a general setting?
It will be a general setting.
So if I apply the configuration about the API gateway to connect to the Terracotta, by default this policy will write to Terracotta. It will not use the memory of the API gateway.
No.
Okay.
So if Terracotta is configured, all the caches will be created on Terracotta and will be used for caching. If not, API gateway will fall back to its own caching, use the on-heap memory for creating and managing the caches.
Okay, thank you.
Okay, so the other useful policies or actions in this policy stage could be this monitor performance and monitor SLA. So using monitor performance, we can raise some kind of alert in case there is a breach or okay, let me first explain what are the different configurations available. So this monitor performance policy action works on some of these predefined parameters or KPIs like availability of the API or fault count or maximum response or minimum response time or total request count, etc. So we can, for example, let's set total request count. So let's say like in case the total request count exceeds 3, there will be, so this is the condition that I can set. And in case this condition is breached or violated, then I can raise an alert, or rather, I can set an alert interval of 1 minute to see during this 1 minute, every 1 minute, whether or not there is a breach of this condition. That total request coming is, total requests are always greater than 3. In that case, I can raise some alert message like this. And I can choose any destination. So I can just decide to capture this log event in API gateway, or I can write it in the local API gateways or server log. Or I can also, if I have properly configured the mail server, I can also send out some email and can define who should receive this kind of alert. So if I now save this API with this, so we can try calling this API. Let me set. So we said like 3 should be the, after 3 requests within 1 minute, there will be an alert raised. So let me hit it couple more times. So from the consumer point of view, there will be no difference because all requests will be processed. However, if I go to the API gateways server log, API gateway log, right? Fine, while it is not logging it here. Monitor request, total request greater than 3. Just let me correct it first. Not sure why it is not appearing in the server log of API gateway. I'm on the right server. Yeah. Also, okay, let's check the analytics. So in the analytics also, it will raise or create events saying that Hello World has this API has got a policy violation. And then we can view the policy details, like which policy was violated, and the custom message that, so event sources monitor policy, and the custom message that we have set in the policy configuration will appear here. So we can decide whether this this alert or this custom alert event, or sorry, the alert message should appear only when for the first time the policy is breached, or it should create such events or raise this kind of alert every time there is a policy breach. So this way we can track whether track performance related KPIs for an API. And there can be like different options available. So we can, as you saw, like the total fault count, etc. Also can be measured. Or maybe if we have set like minimum or maximum response time. Let's say an API is supposed to respond within 1 second. However, for some reason, it is taking more than that. And so if it is happening over a period of time or during or within this alert interval time, then there will be similar alerts recorded in API Gateway's log, or whatever destination we are specifying, either in the local log and always in the API Gateway dashboard. Now, similar to this performance monitoring log, there is another log available, another policy action available, which is called monitor SLA log. Now, monitor SLA log also work on the same set of parameters like the monitor performance log. So here also I can set, let's say, greater than equal to 5. And I can check based on this condition. If this condition is violated, then I can write, I can either write log in my local log, or I can also create API gateway events in the dashboard. So like the other policy, so this policy will be, or this condition will be checked within this alert interval, and every time whenever this policy is violated, there will be an this kind of message will be sent back. Now, this monitor SLA policy has only one differentiating parameter than the monitor performance, that is this consumer application. So by defining this consumer application, so we can create this monitoring policy for either a particular set of consumers or for all consumers. So what will happen is, like, if I'm saying that if I'm setting that my application 2 is the consumer for which I will check this count or this rule, then what will happen is the moment my application 2 sends more than 5 requests within 1 minute, this alert will be logged, whereas for other consumers, this alert will not be logged. So I can define. So this is sometimes useful if we have signed a proper SLA contract with one or more of my consumers. Then using this policy, we can keep track of how many SLA breaches are there over a period of time, maybe in a day. So that way we can have a better track of the SLA for this API. So now I'm going to call this API. So I'm using my application 2's API key. So this will be identified as my application 2. So if I hit the API for more than 5 times, then I will probably see in the analytics that for my application 2 now also is raising this kind of alert. So, okay, maybe not more than 5 times. So here in API gateway I think it is little bit slow for me to capture all the error events, but at least this time in the server log, I can see that SLA event for this API has been violated for this, and total number of requests 5 are more than 5, and application name is my application 2. Now, if I change this consumer to my application 1 and keep hitting the API even for more than 5 counts, it will not log not log any error. So this way we can keep track of which API is breaching. Like we can set a quota for an API or sorry, for an application, or can go into an SLA strict SLA contract with an application or a consumer, and we can keep track of how many times in a day or over a period of time that SLA is breached. So it will ideally show here as well as in the server log, but I think, yeah, now it is showing. So for my application 1, now this policy is shown to be violated because there are more than 5 requests being sent over or within a minute's time. So this way we can do both performance monitoring as well as SLA monitoring for an API. And SLA monitoring can be enabled for either a particular customer, or maybe for all customers, or maybe for a set of customers. So this way we can capture this details. At this policy action stage, there is one more option available, which is for traffic optimization. So traffic optimization allows us to throttle the request throttle the request going to the backend. So my backend may raise or may come with a requirement that they cannot accept more than, let's say, 10 requests at a time, 10 concurrent requests. So if we are experiencing a huge volume of requests, then we can apply this policy here and can limit the number of requests to 10 from going to the backend service. So if if there are more than 10 requests, all other requests will be blocked, and they will not be forwarded to the backend system. So let's set this total request count. I'll keep it very low. If it is greater than 2, then the request will be throttled, and a log will be written in the server log as well as in the API gateway event. And similar to other, like what is the duration? So there is like an alert interval or monitoring duration during which during which time, in case this policy violates, then this policy action will be triggered. So let's set this alert message. And also we can set this policy for any consumer. Backend may have a requirement to stop all requests from coming in regardless of who is sending. Or they can say like, okay, maybe out of 5 consumer, 1 is prone to send too many requests. So maybe we can select that consumer and can say like whenever this consumer sends some request, and we can block them in case the number of incoming requests exceeds the threshold. So let's call this API. So threshold is 3. Threshold is 2. So 1, 2, and 3. So we should see some alert here written in the server log saying hard limit description. number of outgoing requests this, and policy has breached. Now also when the consumer exceeds that threshold after 2 or 3 requests, whatever number we have specified here, consumer will start seeing a different error message this time. So instead of getting a success response, or I mean, in case of getting a response from the backend service or from the API, now they will see this kind of warning message that invocation of this API is not allowed, because this number of outgoing requests has exceeded the threshold limit. So they won't be able to send any request until this duration is over. So the condition is within 1 minute. If they are sending more than 2 requests, all requests will be blocked and they will start seeing this error. After this 1 minute duration, in the next minute, they can start sending request again. So if 1 minute duration is over, then probably they can start sending the request again and can get a good response. Similarly, like the previous two alert setting, we can also see the on the gateway dashboard that this event has been tracked, and it will show like whatever the policy we have configured, the alert message, exactly the same will be shown here. So this way we can monitor the API performance, the SLA, as well as if there is a specific requirement, we can also throttle the request going to the backend. So that's all about the traffic monitoring policy. You may not immediately need to use it, but I have seen this policy is useful in case we are implementing plans and packages. Although like using plans and packages, we can define or set a quota limit for the consumer. At the same time, by implementing this policy actions, we can see which consumer is often breaching the breaching this their plans and the said quota limit, request quota limit, and from there we can take some action by warning the consumer or take some charge for the start metering for the extra request call, etc. So this policy, along with plans and package, we can give us some check on the usage, quota usage by a particular consumer. So with that, we are done with discussing the policies that we can enable at an API level. And remember, these policies can also be applied at a global level. And also the policies can be applied at a scope level. There are some restrictions, like a few policy, I think, cannot be, or not policies, rather the policy actions cannot be applied for at a scope level. I think I had that. Somewhere, like what policy can be applied at a global scope level and what cannot be. So I think, yeah, this slide, which says the traffic monitoring, all actions can be so this table, I think this is also incorrect, because I have seen request processing and response processing can be applied to all can be also applied to a scope level, not just data masking. So there are some restrictions. I cannot remember top of my mind what are they, but out of like all policy actions, I think only a few of them cannot be applied at a scope level, but rest of them can be applied at a scope level too. So with that, let's end this topic unless there is any other questions on the API policies. If not, we will move into the next important topic, that is called threat management. And threat management is important because based on the threat management requirement, we can decide on our API gateway deployment model. So API gateway deployment model is like how many instances of API gateway we need and where in which network segment of my enterprise they will be placed. So I'll just open draw.io because we'll create some diagrams to understand the API deployment model.
Right. About the configuration of the Terracotta inside the gateway. Actually, I didn't find this configuration from the portal. It should be applied from back-end configuration, or because the configuration section, caching section in the configuration, it is not related to any type of external connection.
Yeah. So what happens is we do not specify Terracotta for caching here. So these caches that API gateway create are for their internal use. So there is only one place where we can define Terracotta configuration. So here from under this cluster setting. So although like we are configuring Terracotta for clustering, but the moment we create Terracotta becomes available and API gateway can replicate this caches over Terracotta. Yeah, so there is no specific option, like unless they are in cluster. Normally, unless the API gateway is in cluster, we don't implement Terracotta. And if we have Terracotta installed, API gateway will replicate all the caches into Terracotta. Otherwise, everything will be present on its own memory cache.
Okay. I see now in the cluster there is a type and there is a different type of cluster related to the default, Ignite, and Terracotta. And I thought Terracotta it is have Terracotta server array list. Okay, there is a setting related to Terracotta, but this is a default. And if I set up a Terracotta from here, it will be the default selection for the policy of the cache.
Yes.
And if there is any problem or downtime in this Terracotta, it will be automatically fail over to in memory caching. Or it will fail.
No, so if it is if we are setting a proper Terracotta server array, which will have an active and mirror. So if active goes down, then mirror will become the active node and it will cater to the incoming request. If the entire Terracotta is down, meaning all will reside in the, so API gateway also maintains like a replica of the caches in its local memory. So all will be referred from that local cache. So unless and until API gateway is restarted, or like there is if there is a cache expiry period, until such period, API gateway can work fine using the local caches.
Okay. Regarding this SLA policy related to throttling this, the performance, the monitoring about this SLA. It shouldn't be inside the developer portal and the configuration of the application itself. It shouldn't be part of this.
See, See, the developer portal only like it acts as a facade for the API. So imagine instead of using SOAP UI or a REST client, I'm using developer portal to test the APIs. But at at an actual invocation time, like when so developer portal is just a marketplace where I can pick and select the test drive the APIs and can finally decide what is my API to be used. And accordingly, I can subscribe to the plans and packages. Now, when the consumer starts using the API, they always call the API gateway. They do not call developer portal and that they do not invoke the API via the API gateway. So all this policy execution, the API invocation, all happens on the gateway. So there is no point we move these policies over developer portal because at runtime, developer portal has no role practically. So developer portal is just like a window for you to identify which APIs you need, what you need to do on your client coding side to call the API. But when you hit the API actually in real time, it always API gateway that gets the request. So that is why all policy are configured in API gateway and all policy execution always happen in API gateway. So even when we talk about plans and packages, they are created, maintained, updated, everything like counted, the metering activity that always happens on the gateway side. The information is only sent back to the developer portal. You got my point, right? So that is why, in actual runtime, developer portal is never used. So it is always between consumer or the application and API gateway. So that is why all this configuration we need to do in API gateway, never in developer portal. And also we cannot do so because developer portal doesn't have that facility to configure any of these policies. If this policy is configured, the maximum developer portal will show that these are the kind of policies that are being assigned. I think it shows the policies that are assigned to it. I can't remember correctly, but I think it just shows, it gives a meta information about what are the policies that are assigned, but actually it does not. Execute or does anything for the, let me publish this API. So from the policies view, we can see, okay, hard limit is set that there is 2 invocation per 1 minute. Further request will be blocked. There is this API, API key check policy and evaluate JWT token and etc. So apart from that, no other information will be shown. All these are like traffic limit policy to protect the backend service from being overloaded. So traffic optimization, identify and authorize. So these are only maintained here. Is it clear or you still are in doubt?
It's clear.
Okay. So coming to the topic of threat protection or threat management. So threat management is important because, and especially important if we are exposing the APIs to external customers. So external customers the request can originate from any internet domain. So if we do not have proper threat management or threat protection policies enforced or some tools present to do a due diligence on the incoming request, then we may end up opening our APIs to or making our APIs or anything like services or the whole enterprise level applications, everything vulnerable to or susceptible to cyber attacks. So in order to prevent such cyber attacks, like prevent hackers from sending unnecessary requests, or they sometimes send shamble TCP packages to block the entire network and thereby bring down the whole application or the whole enterprise level network. So in order to prevent that, API Gateway, if we are using API Gateway comes with a different functionality or an additional feature of threat management. Now, there are enterprises who use their own threat management tool. There are many such tools available in marketplace. Or if the customer is using private cloud on Azure or AWS, they can additionally enable WAF or Web Application Firewall, which does the same thing. So the WAF or similar threat management tool can verify whether primarily they do the IP whitelisting. Also, they can send or set some threshold for incoming requests. So if they see like there are too many incoming, let's say 5,000 requests coming in 1 second, that may raise an alert that there is something wrong or someone is trying maybe a brute force attack on the network, on the API and hence on the network. So if an enterprise has their own tool to do all this kind of checks, then it's okay that they may not want to use API Gateway's threat protection tool separately. But if an enterprise doesn't have any such means to check the origin of the request or do IP whitelisting of the possible sources, then in that case, we can propose API Gateway's threat management feature. Now, when we say API Gateway's threat management feature, so basically it is like, or we call it normally API Gateway Threat Protection Layer. So it is basically the same API Gateway with an additional policy, threat protection policies enabled. Now, when we want to use API Gateway to do the threat management or threat protection, we can adopt different deployment model and can decide where the threat protection layer will be, where or rather which API gateway will do this threat management and which API gateway will handle the normal API calls. So normally what happens is like, let's try to draw some. So let's call this as the external firewall. Outside of this is the public internet domain. Domain or WAN, and most of my external consumers are sending requests from WAN area. So normally after this external firewall, we have something called a DMZ layer. This is called DMZ or demilitarized zone. And then we have an internal firewall or enterprise's own firewall. And then we have the green zone or the like all the enterprise applications are usually they usually sit in the green zone. So this is like protected by the internal firewall. Now, the API that is responsible for handling like all the incoming API calls, I mean, process the request, send the request to backend, etc. Normally, we place that API gateway in this green zone. So let's call this as my backend application. Backend app 1, and similarly I can have multiple other backend applications. So normally we place the API gateway that does this API request handling in this green zone, and we call, or to differentiate, we call it API gateway mediation layer. So this mediation layer, if we want to, like what we are now seeing, like where all these APIs are created, etc. This mediation layer is nothing but API gateway, and it is using the advanced edition of the API gateway license. So if you see the licensing configuration, you will see the license details. You will see that the product code is AA. So this is the advanced edition, which is capable of managing APIs, policies, applications, can handle all the incoming requests, send it to backend. So this is how the flow works. So consumer sitting in the public domain sends the request, and it crosses these firewalls, and finally it ends up being here, and then API sends the request to backend application, and then the response goes back to the consumer. Also, I can have internal applications. So maybe this application is calling API gateway, and API gateway is returning the result to this application. Now, in this scenario, what I said, like enterprise can have their own tool for doing threat management. So they have their own threat management tool, or there can be WAF if this whole thing is on cloud. If nothing is present, or if we still want to give another layer of protection, then we can bring in this API gateway threat protection layer in between. So API gateway threat protection layer is again, it's the same API gateway, but just for doing threat management, we normally choose the license type as API gateway standard edition. So I have installed both API gateway. I have two API gateways running in my local. So one is the one API gateway is what we use so far for creating all the APIs and all, because it is using the advanced edition license. The other API gateway, it's a different port 19072. If I log into this API gateway now, you will find there is no other, no option for creating any APIs, nothing, no applications, no policies, nothing. So only the threat protection policies can be configured. And this behavior, the differentiation, like what API gateway can do, is controlled by the license. So the threat protection license has the product code called, I think SA. So this is how we can differentiate between a threat protection API gateway and a mediation API gateway, and can have two separate installation, one dedicatedly doing this threat protection activities, and the other one capable of doing all mediation activities. So if we have this kind of setup available, then this calls this architecture is normally called a layered deployment architecture, not layered, sorry, a paired deployment, paired model, API gateway paired deployment architecture, where we are always pairing a threat protection with a mediation layer. Now, in this in this, normally, if we have to also use developer portal, normally we keep developer portal in the same DMZ layer, because developer portal or API portal is also used by the external clients. So it makes much more sense that we keep developer portal running in the DMZ layer, so that when someone does try API calls, I mean, when someone tests an API, the request is not forwarded to the actual mediation layer. Rather, it goes to something called a sandbox API layer, which is like a replica of my actual mediation API, but it is again sitting in the green zone. Sorry, in the DMZ zone. So any malicious request that can come to developer portal and go to sandbox is all contained in the DMZ layer. So never forward or route the request to your internal API gateway from developer portal. So be very careful where you are placing your developer portal, and accordingly choose what API gateway should be used for allowing the users to test API via the portal.
Okay,
So that's
about
the
this,
step.
about
Yeah.
the sandbox for API testing, if I try to send a request to the developer through this developer portal, it will send it to the sandbox, which it is like a mock service from the API. The API is hosted inside the API gateway, and the same action or the same back-end calls, it will be done through this sandbox, or what is the exact happening here?
See,
the traffic now go through developer portal to the CSS sandbox, then the back-end direct?
no, see, if you forward it to backend again, you will end up again exposing or like some malicious request can again target your backend application, right? So in that case, the API gateway, this sandbox or this API gateway will have all similar configurations, API configurations of this mediation layer, but we can definitely mock the responses so that it doesn't forward the request to the actual backend application.
But we're based in the current tool in the market, and we was like what we have like in the Azure API gateway or Apigee gateway. The developer portal, this is not the actual. It is not acting like this. It is actually you retrieve data from the back end.
It depends on the customer how they want to place their developer portal. This is like a safe option because you are not at any point, only when you know that there is someone willing to actually use your APIs and they are going to take the subscription and call the APIs. Until that point, you restrict everything in this domain. Now, I mean, if okay, I know what you mean, because you are saying like when the application is created, that is actually connecting to this actual API gateway. So yeah, that also is possible. So I have seen one implementation like this where they have created this developer portal and API gateway mediation in the sandbox in the DMZ zone for everyone to test. Only like, and they have configured approval workflow in such a way that when someone requests for application creation or mainly subscription creation, the subscriptions are created and they are routed to a different developer portal altogether. So instead of using this, they are told to use a different developer portal altogether. And this developer portal, by proper connection means, is connected to the backend API gateway. So I have seen this kind of implementation also where developer portal, like 2 different instances are maintained, where one is like given for test, etc. purpose. And whenever the plans, someone requests for subscription, etc., they are routed to a different developer portal, and from there they can connect to the gateway. So if you do not want to get into that level of complications, so you can always have one developer portal available, and this will always be used by your external customers to try API, as well as when they are ready to subscribe to some APIs, they can, via the same developer portal, they can do that. And in
Yes,
that case, yeah.
Yeah, because the only configuration I saw in the API gateway, this is the configuration between the developer portal and the gateway. It is a single configuration only. So I
Yeah,
didn't see
same
something like
configuration.
related to sandbox inside the developer portal configuration,
No,
or
it
from the
won't be
gateway.
called sandbox. It is like another pair of API gateway and developer portal. So it is like
So
sandbox as in like,
how the product and the packages moved from how to publish the API from the gateway to the portal now. If we
no.
move
So
the gateway again.
see, this is just like a replica. So this API gateway is replica of this one. So whatever you are creating there, you can create or configure everything there, so that they can get some idea. The consumers can get some idea what is happening of or what is there for an API. So they can view, test everything they can do here. But when they want to actually subscribe something, the approval workflow can control, or they have control. And let me tell you one more thing, that they have their own approval workflow, which was later or at some point hooked to API gateway and developer portal workflow. So you can configure the approval workflow in such a way that whenever someone is requesting for an actual subscription, they are routed to this actual developer portal, and from there they can call the actual backend. So if you are maintaining this kind of setup, then always there is a task for you to keep this API gateway and this API gateway in sync in terms of all API configurations, policy configurations, etc.
Okay, it seems like still also it is
See,
too
and
difficult to
also,
apply a kind of this configuration, because you cannot able to keep all APIs inside the gateway, advanced gateway. I think it was the API mediation from the DMZ, because you need to do extra changes related to mocking these APIs and broke the connection between these APIs and the back-end systems.
yeah,
Also,
I'm
yes,
not saying this is an easy configuration to maintain, but if the customer, I mean, I have seen the customer is very particular about, because they are coming
mm,
from a banking domain, so they don't want like anyone
okay,
to call their backend application straight
right,
away.
right.
So because of their very stringent security requirement, they were okay to take this manual activity or additional effort of maintaining or syncing these two API gateways to
Yes,
keep
valid,
all
valid.
the APIs and all in sync, the
Yes,
configurations in sync.
yeah, maybe right. You're right. Maybe some sensitive data maybe to be
Yeah, I
isolated
mean,
from the
like,
actual data. Yeah.
yeah, so they tried to mock the APIs as much as possible. They were happy to do that, but they didn't want this connection to come straight away here for like for a first time user or something. So that is why they adopted. But I'm not saying this is the ideal model or always this has to be applied. This is just like another option for you to choose.
Okay. Type about this API threat protection layer.
Hmm.
Um, most of the time, this API it is behind a load balancer or F5 virtual IP.
Yeah,
So how it
yeah.
will detect this IP filtering, and because most of the request is forward through this this load balancer. So maybe it all consumer seems like single IP. Is there any additional configuration needed to done on the F5 to allow API gateway to get this control on IP received that the traffic received from?
You mean this at this thread protection here?
Yes, and if the
Yeah.
traffic coming from the public, it will hit
yeah.
a load balancer, which it is
Yes.
AMOE.gov.sa, which it is actually it is not, and this traffic it's coming to this service, and it will appear like all traffic coming from the same source.
Okay, I am not aware of exactly what parameter to be set on the load balancer, but we can have the load balancer set up in that way that it can actually forward the client IP, the source IP.
Yeah.
So maybe this is something you can check with the F5 team, how they can forward the actual source IP, not just send the load balancer's virtual IP.
I mean, there is no additional configuration needed to be done on the gateway itself.
On the gateway, there is nothing to be done, but it is something to control at this LB layer. Okay. So coming back to this paired deployment model, so if we are adopting this kind of paired deployment model, so what happens is normally like in our normal QA, or if QA has like a requirement for testing involving the external customers, then we can have only one node of this API gateway thread protection and one node of API gateway mediation, and the request can flow from thread protection to mediation. Now in production like scenario, the API gateway thread protections can be like there can be more than one nodes. So we can have two nodes. So the request from external customer will hit the LB, and LB can redirect the request to any of the available thread protection node. So remember this thread protection node, although we are like creating different instances, they are all acting individually. So they are not in cluster. Like for mediation layer, we can set API gateway cluster by creating adding minimum 3 nodes. So they form a cluster amongst themselves. So we can set up such API gateway cluster. But for thread protection, there is no clustering concept. So even though there are 2 or more nodes available, they all will be acting as an individual node. Okay, so there is no clustering concept at all, and hence we do not need Terracotta anything for this API gateway thread protection. So if we are going for this paired deployment model, we do not have a need for installing Terracotta and the DMZ layer for supporting API gateway cluster, because they never need that kind of clustering. Now, the question is how API gateway thread protection forwards the request to the green zone. So this is one of the advantage of using API gateway thread protection, because the connection from API gateway mediation layer to thread protection layer is controlled by something called reverse invoke connection. So excuse me. So in reverse invoke connection, the connection is established or work mostly in a listener mode. So what happens is in thread protection layer, we configure 2 ports. Rather, we create like a paired port. One port is called the external port, which is exposed to the consumer via the load balancer, and the other port is called here the registration port. So they are always created in pair. So what will happen is when the request comes to external port of the thread protection, API gateway, like the reverse invoke policy, the reverse invoke connection forwards the request from this external port to the registration port. It is handled entirely internally, so we cannot do we need not configure anything extra for this to work apart from configuring this external and registration port. So request comes to external port if and then like if thread protection policies are configured, API gateway runs all the policies. If the request passes those policies, then the request is forwarded to the registration port and the request waits there. Now, mediation layer, on the mediation layer side, we create a port called internal port. We create something called internal port, and we direct this internal port to this registration port. So API gateway. So if you notice in this case, the request for request propagation is never from API gateway thread protection to mediation, meaning there is no downward arrow from here to here. Rather, API gateway thread protection, when they forward the request to registration port, API gateway mediation opens this reverse invoke connection from internal to registration port and pulls the request. So it works in this pull mode rather than push or forward mode. And this way, the advantage is in case your DMZ is breached, in case your DMZ API gateway thread protection is compromised, thread protection layers are compromised, all you can do is you can disable the internal port on the mediation layer and the connection will be completely cut off. So you still have some chance to save your internal application from being further breached. So this connection is always like going from mediation to thread protection layer. And if we have multiple thread protection instances available in the DMZ, the mediation layer will open ports to each of this thread protection layer. So always the connection is also like it's overlapping, but yeah, let me try to clear it up. So always these connections will be created in a one-to-one fashion. So API gateway mediation will have two connections created, one to this thread protection one instance and second and to the and also to the second instance of thread protection. Similarly, API gateway, if API gateways are in cluster, there are more than one API gateway mediation nodes. It can also open a connection to thread protection 1 and also to the thread protection 2. Similarly, API gateway, the third node, the third mediation node can open connection to this and can open connection to this. So as you can see, there are total of six connections. All are working in a one-to-one fashion, and all are initiated by the mediation layer to their to the respective thread protection nodes. In case if we want to disable the connection, all we have to do is go and disable the internal ports, and thereby all the connections will be removed from thread protection. So this is how the reverse proxy works. And for this reverse invocation works. And in order for configuring the reverse invoke, we just have to configure the external and registration ports on the thread protection layer and an internal port on the mediation layer. That is if we are going for this kind of paired deployments. And there can be, okay, so this since like this connection is always this reverse invoke connection always is originated from mediation to registration, and also they are one-to-one in nature. So there is really no need for applying a load balancer layer in between, because I mean, we can do so, but there is no point, because in case this threat protection one is going down, so API gateway mediation loses the connection to threat protection one node. So this connection is down, but this connection is still available. So there is actually no need for load balancer to detect whether the threat protection node 1 is down and forward the request to, or forward the connection to a session to the node 2, because the connection is already established to node 2 of threat protection layer. So if required, you can try exploring if like if we can bring in a load balancer in between, like the reverse connection, reverse invoke should happen, or in this case will happen via this load balancer. But actually there is no need for this load balancer, because the connections are always one-to-one and persistent in nature, and always initiated by the mediation layer. So this is like the internal LP, and this becomes optional in most cases. Frankly, I haven't seen except one customer, and I cannot recall if they were successful in implementing this, but I haven't seen anyone using a load balancer here. Like now, API gateway mediation can have a load balancer in between, and this load balancer can be used by any internal application. So let's call this internal LP 2. And so this load balancer can be used by any internal application that is going to call the API gateway. That too, like if API gateway nodes are in cluster. If one-to-one, only one node is available, we may not go even for a load balancer. So this is like the normal architecture we follow in case of a paired deployment model. There are some, I mean, this architecture, if we are implementing threat protection features, then this kind of deployment model is recommended. We can always separate the threat protection functionality from the mediation functionalities or capabilities. And also we can isolate or contain all the threat filtering happening in the DMZ layer, and thereby can keep my other API, the actual API configurations, etc., safe in the green zone. Now, apart from this deployment model, rarely, I mean, technically achievable, but not recommended. That is called like a single deployment model, where we can have only one API gateway placed in the DMZ layer, and all other, I mean, all requests are coming to this gateway. This gateway is capable of doing both threat management as well as the mediation functionalities. So let's try to draw that. Let me just. So in single deployment layer, so everything will be same up to this point. We'll have this load balancer placed here. Requests will come to API gateway. So this is like an API gateway. TP plus mediation. So here, if we are going for a single deployment model, then this API gateway must use always the advanced edition license, because alongside alongside running the threat protection policies, it also has to do the actual API management. So request will come to this this mediation plus TP layer. And in production like scenarios, for HA requirement, we can have minimum of 3 such nodes all in cluster. And also if we are clustering, then definitely there will be a need for installing Terracotta at this layer. So yes, to avoid all this, we say like keep the thread protection separate from the mediation. So in this case, the reverse invoke can still work. So reverse invoke like a proprietary policy of or proprietary protocol of web methods. So no legacy technologies like Java or core technologies like Java or .NET can replicate that or can create client libraries to connect to my API gateway server using reverse invoke. So if we are using this kind of model, so we always have to have an integration server in between. So on this layer, we will have this, I think, we can have like when API gateway forwards the request to my backend, it can land to this, it can come to this IS and then it can go to a backend application. So this IS will act or will initiate that, rather this connection will be like this. So this IS will have, it will be a pass-through IS just for supporting these reverse invoke connection, and it will have the same internal port created here on it, and then on the API gateway side we will have like all this external registration and the external and registration port configured. So we can achieve this also, but just that we need an integration server in between. As far I remember, this is the requirement for single deployment model. So this is like technically achievable, but not recommended. So I'll not focus on this too much. I will focus on this paired deployment model. So, or any questions on this single deployment model or any other information needed, I'm happy to clarify. So in this paired deployment model, as I said, like we will have 2 different API gateways. So I have in my local 2 different API gateways. So if I go to my installation directory, I have this mediation layer and I have this thread protection layer. So mediation is called using this 9072 port, whereas thread protection is called using this 19072. You can choose any ports since they are all in the same machine. So I had to be a little creative in terms of defining the ports. So first thing we have to do is configure the ports for the external and registration pair ports, and then on the mediation layer, the internal port. So I have pre-created all these ports, so we can create the port. This is the thread protection API gateways web UI. So from here, we can come to this ports option, and we can create an external port and registration port. So let me show you what information we need to select. So we can just select API gateway external port and it will open this option. So we can say like ext port alias 1, and this will be the port number actually. So let's say 9001 is my external port and some description. So this port can be enabled on HTTP as well as HTTPS, most likely HTTPS since this is exposed to the external consumers. And then under security configurations, if you are, If we are creating HTTPS port, then we have to also have this listener specific key store trust store configured. And then we can, as I said, like it is external and registration are always like paired ports. So we have to add a paired port, a registration paired port here. So let's call it and then also this registration port can be on HTTP or HTTP protocol. And if HTTPS, then we can configure the necessary key store trust store. So let me just revert to HTTP. And if we add, we will see that these two ports got created. So, so we can enable them together and they will start working. So I have created previously this 8889 and 8877 port as external port and registration port, and we will use that. I'm not using 901. I think my is using 9001. So there could be a conflict. So I'm not enabling this port. So now we are done with external and registration port configuration. So we can go to the internal or mediation API gateway. And as I said, like we have to create an internal port here. So same thing from the administrator security feature, from ports option, we can create the internal port. Now notice when we are configuring the internal port, so we can always select internal. Here also we can decide whether the internal port will use HTTP or HTTPS protocol, and then some alias name for this. And then when actually defining the port number, so we give the port number like this, the host name and the port number. So let's say 9002 was the port number. And then the registration client. So since like as per the diagram, the connection is always initiated from mediation to mediation internal port to registration port. Hence, we can apply some authentication to for authentication to see whether it is the right mediation server that is requesting for this connection. So here, when defining the registration port, while defining the external registration port pair, we can select what should be the, let me go to the actual. We can select what should be the security configuration. So we can say like client authentication means what authentication the mediation will use to connect to this registration port. So if we are using SSL, then we can also add require or request client certificate for this connection to work. Otherwise, we can just use use username password based authentication. So since I have configured username password based authentication at the registration port, it means that we have to set a value, a username password for this to work. Now, I'm keeping this as username, administrator manage, because this user is present in all instances. If we want to use any custom user, we have to first create that custom user on the threat protection layer and then configure that user ID and the relevant password here. So this way we can add the we can add the internal port. So I have already created the internal port here, which is 8877, and it is using the registration port 8877. So this after invoking the after enabling the port, this will look like this. Additionally, to see, okay, no, yeah, so this much is sufficient. Okay. Now we can set another property or another, we can configure another setting on the mediation layer to say what will be the load balancer. So, why, sorry, let me rephrase it. We can, after configuring the the internal port, we can configure a load balancer settings. Now, why this load balancer setting is needed? Because now all the requests are going to come from external to the internal. So the request, the external consumer will hit the external port called 8889, and then that will forward the request to my internal port. So if we do not configure the load balancer protocol, load balancer URL here, so what will happen is when I publish this API or expose this API, the API definition will still say like will still use the the normal port, the 777 port, saying like on this port the request can be sent. To abstract that information, we can configure the load balancer URL here using the threat protection, the external port, and if we see. So before I configure this, just let's see the difference. So any API, if I open, it is showing that gateway endpoint is using 777, the API gateway's own ports. So we can abstract this information or abstract this port from being seen by anyone by configuring this load balancer here. So now for any API, the gateway endpoint will reflect that 8889 port is there. So because I haven't configured any HTTPS URL for the load balancer, only HTTP endpoint got changed and it is reflecting 8889 port. So now I can invoke this particular Hello World API, or for that matter, any API using either 8889 port . Have those policies enabled. Yeah, so I can hit the API using this port or 777 port. But normally when we share the endpoint details with our external consumer, we always must use that external port called 8889. We should not share our internal port. So all requests will now start to come via the threat protection layer as long as this ports are configured and they are connecting. Now, coming to the topic of threat management. So this is the basic requirement or prerequisite configurations that we need to do on both threat protection and mediation layer for the threat protection policies to work. Now, the actual threat protection policies we configure on this threat protection layer. So from this policies, we can enable any of the threat protection policies. So there are two policies available ready to use. Ready to use meaning like I have configured them. But these two policies are like global denial of service and denial of service by API, by IP. These two policies are used to throttle the request. So global denial of service. So normally under a cyber attack, so the first thing the cyber or the hackers do is that they keep sending enormous numbers of packages or request packages to API. So if we see there is a sudden growth in the incoming request, then that can raise some alert. And using this global denial of service policy, we can set some threshold saying like, for example, maximum request within 1 second. If it exceeds, two maximum requests in 1 second is possible, while one request is still in progress. If there are more requests coming, then we can take an action to block all incoming requests and send an error message back to the consumer saying that all requests are blocked. So this policy will, irrespective of whether or not the request is coming from a trusted source or from an unknown source, it will block all requests. So it will stop all consumers from sending further requests. Now, if we know for sure that that some requests are coming from a trusted IP address, then we can set this IP address here, and only consumers using those IP addresses will be able to send the request. Any IP address that is not specified here will see that their requests are getting blocked. So this is kind of like whitelisting the IP or adding the trusted IPs to allowed list even though we are putting all requests on hold, but still we can allow some requests to come to. So if this policy is enabled, so let's see, we will invoke. So after 2 or 3, I think 2 requests, the request got blocked, and I'm immediately seeing a status message saying too many requests, all requests are blocked, which is exactly what I have configured here. So now this message will be returned back to the consumers, to all consumers. If I add an IP, let's say I'm adding star here. Oh, IP is not valid. Okay. So if I add my localhost IP, that 127.0.0 something, I probably can still send the request. Now, as an action of this policy violation, we are blocking the request for 5 minutes. So I have specified an interval of 5 minutes. So if I continue, since 5 minutes not over yet, if I continue sending the request, I will still see that this request is, this message is coming and my IP got blocked for 5 minutes. So if within 5 minutes I'm removing my IP from here, if I'm deleting the IP from the blocked list, then again I'll be able to send. But again, like since I have breached the quota, so breached the limit, so again my IP got blocked. So this way we can block all requests irrespective of their originations. So this is one policy. So we can also increase the block interval because there may be cases where we need someone to actually review all the blocked IPs whoever has breached rather all blocked IPs, to decide whether or not it is safe to unblock all the IPs. So we can increase the the block interval period to give or allow the administrator sufficient time to review all blocked IPs and make a decision whether or not to unblock them. So this is one sort of policy. Then as the variant of this blocking policy or throttling policy is this, that denial of service by IP. So we can we can configure this policy and same condition, like maximum request to in 1 second while one request is still under process. So we can configure this policy to either add an IP to a deny list permanently until someone goes and removes, or we can block the request. So if we block the request, there can be some blocked interval. So let's say for 10 minutes, I'm blocking the request, or I can add the IP to the deny list permanently. So any other, so this is like works based on the IPs. So all other consumers, whichever IP I'm not blocking, all other consumers will still get, can still invoke the request. However, the blocked ID will no longer be able to send the request. So similarly, if I hit the IP too many, this API too many times, then I'll see now there is a different error message being written that says too many requests are breaching this policy, all requests are blocked. And similarly, as before, my IP will appear on this blocked or denied IP list. And I can unblock or allow, again, like remove it from this block list. Also for this policy, if required, we can set some trusted IPs, but only when we are certain that these IPs are really like some known trusted sources. Otherwise, we should not do that. Okay. So this is how we can configure global denial or denial of service by IP policy to throttle the incoming request and stop them at the threat protection layer itself. So they will not be forwarded to the mediation layer. Now, apart from this, these two policies, these two throttling policies, we have several other custom rules available, which can be used for doing threat protection or doing threat management. Now, one thing I did not mention. So whenever we are configuring this kind of policy like global denial of service or rules, etc., additionally, we are blocking the request or putting the IPs or whitelisting the IPs, etc. These are fine. But at the same time, we can configure some alert emails to go out. Now, we can configure this alert email here, from this option. So what will happen is whenever policy is breached, alert email will be sent for them, like based on this condition. So either on rule violation or every 1 minute, and we can define who should be the recipient of this email. Or also I can additionally call some flow service. So this flow service again will be residing on the integration server of the threat protection API. And this flow service can do some processing, further processing, custom processing, and can forward, we can achieve some integration with Tivoli or service desk to, like, whenever this policy is breached, I will raise an incident, and I can achieve that kind of integration from this flow service. So if there is a requirement for do so we can always adopt a flow service to forward the information to create an incident in the service desk. Your IT service desk. So whenever we are configuring alert settings here, this is kind of an global alert setting, which will be applicable to all the policies that are configured here. If we do not want to do so, we have an option of configuring alerts at the individual policy level. So for global denial and denial of service by IP, if we want to send alerts for these two policy breaches, then we have to have this configuration there. We can also overrule this configuration by creating configuration. So if we have, let's say, along with global denial of service, we also have message size filter rule enabled, then we can do a custom alert setting here, which will override this global alert setting. So if we choose the default option, meaning it will fall back to this alert setting that we have defined here. Custom means we can define our own alert settings. So maybe for rules, maybe for this global policy, I just want to send alert email, whereas for message size based filtering policy, I want to additionally raise a service desk incident. So based on the requirement, we can do both. Now we have different rules available. So we can create a rule name here, and we can say we can create what action to be taken. So either deny the request and alert, or maybe simply raise an alert and allow the request to come through. And we can define also what will be the custom message, because the error message, because this error message will be part of the alert email, as well as when we view the breaches from the dashboard, this error message will be shown over there. Now, there are several threat protection rules available: message size filtering, OAuth filter, SQL injection, JSON, XML threat protection filter, etc., or antivirus scan. I'll just quickly describe each of them, what they can do, but I have no means of demonstrating them because these are very difficult to replicate. So only like professional penetration testers can kind of create this kind of threats and can verify these rules, whether they are working or not. I'll just describe what each rule is capable of doing. So message size filtering, so we can enable this rule and we can define a threshold limit, let's say 2 MB. So if there are messages, enormous messages like 10 MB, 20 MB messages are coming, then definitely this rule will be violated. And according to the rule setting, either an alert will be raised, or the request will be blocked, and also an alert will be raised. So this one checks the message size. OAuth filter is if someone is continuously creating so this policy checks whether OAuth token is coming or not. So if I'm not quite sure how it will detect if OAuth token should be verified, because a customer can also send some other tokens, other identifiers. So I'm not quite sure how it works just by checking required OAuth credentials. Oh, no, sorry. This one is not for OAuth, but when someone is going to request the OAuth token. So, so for requesting OAuth token, they need to send some credentials. So if those credentials are not sent, yet the OAuth token retrieval API or the URL is called over and over again, then that can raise some red flag. So similarly, mobile application protection filter. So if the request is coming from some mobile device, we can enable this rule, and we can have this mobile device and apps list. predefined list where we can say like these are my allowed device. For example, Samsung or Apple, these are allowed devices. So request can only originate from these devices. If the request is coming from a Nokia phone, I should not allow that request to come through. Similarly, if the request is coming from a particular mobile application, let's say Gmail, so I want the request to come from a valid application, like always Gmail should send this kind of request. And also we can define in the rule, we can define like if mobile applications are configured, then what should be their minimum version, like what version of the application can send the request. If the condition is not matching, then the request will be rejected. So we can create a combination of, let's say, device type Samsung, application is Gmail, condition is that mobile app version should be so and so, like let's say Gmail version 9 is required. Then only the request will be passed, or otherwise the request will be blocked. SQL injection protection filter. So we can enable this rule to check whether there are any SQL injection. So this rule can be database specific. So we can choose what is the SQL server, so MySQL or Oracle or not. And we can define which parameters to check for injection logic. If we select standard, sorry, I think it's one or the other. Standard SQL. Oh, I think if we select the standard SQL injection, it will check only certain parameters. We can add more parameters, then all of these parameters will be verified for SQL, any malicious SQL request. Antivirus scan. So antivirus, we can, after the request comes to API Gateway Threat Protection, we can route it to an antivirus software that usually runs in the DMZ layer to do some antivirus scanning. So we have to have the ICAP name, that is the antivirus software's URL, and I mean the name and the host IP and address. So if this rule is enabled, so all requests will now be forwarded to the antivirus software for scanning, and then only it will come back to threat protection gateway, and then from there it can be forwarded to the mediation layer. So JSON threat protection and XML threat protection filter, they work in the same fashion. So they see that one thing they check, that is the depth. Like if there are abnormally nested elements present, then that can be considered as a potential threat, or the object entry length. So if any object has a huge name or a value, that can also be like some malicious code has been embedded in those fields. So that can also that can be treated as a potential threat. So we can define the object entry name length and the string value length. And if the input has input request has object entry name greater than the threshold value, or the value itself is greater than the threshold value, then it can then this policy will be breached, and the request will be blocked. Similarly, for XML, there are few more additional parameters like the name space prefix links, etc. So based on the requirement, we can configure these parameters and enable this rule. So at runtime, all these parameters will be verified. And lastly, we always have a custom filter. So custom filter is nothing but calling an integration flow service. which will be hosted on the API Gateway Threat Protection IS. And this can, like, if we see that these conditions are not sufficient to do a check, then we can always invoke this custom filter to do additional checking, and based on that we can decide whether or not to block an incoming request. So I'll leave it to you. If you have actual need and if you get access to a threat protection layer, you can explore yourself these rules to see how they work at runtime and how to be configured. So yeah, but theoretically, this is what we can do at the threat protection layer, and we have several options to implement. Almost all common rules we can implement in this threat protection layer. So any questions on this threat protection functionality or on this deployment model? So if not, we can take a quick 10-15 minutes break, and we can discuss some other pending topics on API Gateway. I think one was related to webhook. I have something to discuss, and I also want to show how the API mashup works. That can be interesting for you. So any question on threat
Yes,
protection
regarding
functionality?
this threat protection about the
Hmm?
antivirus rule.
Which rule? Sorry?
The antivirus rule.
Antivirus. Okay.
Antivirus, yes. This is a global policy for the all gateway, right?
Yes, all gateway.
But we cannot specify this rule against an endpoint or a URL or a specific API inside the
No, unfortunately, no.
because not all requests should be go to the
Yeah, yes,
maybe
yes, I
maybe the
agree.
uploaded file only the endpoints has a file or attachments.
Correct, correct.
We already have the case like this, and we enforce it by security to move these files to the antivirus scanning point before saving the file or attachment inside MWE. But here we need to forward all traffic to the if it will affecting the all API performance.
Yes, yes, I agree with you. I completely agree with you. If we enable this rule, it will be applicable to all incoming requests. So I don't think we can filter out certain requests to be send certain requests to the antivirus software.
Okay, even maybe we can okay, maybe we can make a dedicated threat protection endpoint for this API related to the files and keep other for a different a different endpoint, maybe, because this is a single instance of the API, right?
Okay, so what you mean to say, if I understood you correctly, so what you are saying is you for just for this rule, you will use one threat protection instance, and while other requests can come via the other threat protection instance.
Yeah, because this is the you told me this is too different, and there is no clustering in this. It
Oh,
shouldn't
there
be
is no
clustered there, so it shouldn't be typical setting. I need to configure each one with its own configuration.
Yes. So yeah, you can do that keep this rule enabled in one node, whereas the other node will do other functionalities. And so consumers sending this kind of files, etc., can always send the request to, let's say, API Gateway 1 threat protection node, and all other consumers can send. But in that case, you just have to adjust your load balancer. Also, you need to keep in mind about the high availability requirement of this threat protection layer, because what now is going to happen that you only have one instances each for doing this function. So so out of this two node, one will be only doing this virus scanning, and the other node is going to do rest of the threat protection activities. Now, as I said, like this connection. So, for instance, this if this API gateway goes down, then there is absolutely no one to do. There is no alternate node available to do this virus scanning. So that functionality will completely stop. So similarly, if this node goes down, then there is no alternate node available for doing the other global denial of service, etc. Rule validation. So yeah, if you are separating the functionality, probably you will end up creating more nodes here just for just for meeting your high availability requirements.
Right. So maybe we can, okay, so we don't need to. So, okay, so I feel like there is no point from using this threat protection layer.
No, okay, see, I mean,
because most of the threat or the throttling or block IPs, it is done actually from the first layer of the gateway of the firewall. And it is no additional.
No, absolutely. Like you may not find not every project require this threat protection layer. Also, I can recommend you one thing, that if you have if you know there are a group of consumers or group of applications are going to upload this file, maybe for only for those consumers you set up this layer which will be capable of doing this threat protection virus scanning. Let all other consumers come directly to your because you already have this firewall and LB, which is doing this IP whitelisting, etc. So you can allow all the whitelisted IP directly to come to your internal gateway. And customers who are going to send this file, you always know that who is going, if you always know that who is going to send this file, maybe route those requests via this threat protection layer enabled with virus scanning. That is another option that you can try out instead of completely removing it. So yeah, I can think of that as an option. Up to you to evaluate whether that will be useful or not.
Okay, clear.
Okay. So shall we take a quick 10-15 minutes break, and then we can discuss the other topics? I'll meanwhile see what are the remaining topics for API Gateway. If I have some time today, I would like to cover Centra side, and tomorrow we can focus entirely on developer portal and any other API Gateway related topic that you may want to review or revisit. So that's my plan.
Okay.
So let's break for 10 minutes.
It's okay.
Sure. Thank you.
Thank you. Yes, we can resume.
Okay, fine. So, okay. So yesterday we were talking about, I think you were asking about webhook API. So I did some checking internally. So about the webhook API, from the webhook API as such cannot be implemented, but there is an option available for callback API or asynchronous API. I wouldn't say webhook API cannot be implemented. The way of implementing webhook is via the asynchronous API or via the callback API. I saw there are some restrictions in creating callback, and at this moment, it seems like callback is available only for the REST API. So for SOAP, I did not see an option of configuring callback. So callback APIs are like, so I tried to prepare a callback API, but just uh, well, I mean, I did the configuration, but I need to also do some development for it to I mean, fully work. So, what happens in case of callback APIs or for asynchronous API is that, like so far, what we have seen, they are all working in synchronous mode. That they are somebody is sending a request and immediately getting a response back. Now, as opposite to this requirement, there can be scenarios where a consumer calls an API. The API has to do lots of processing, and the response may not be available immediately. So we can always give another URL to the consumer to so that they can keep checking what is the status of the previous request or the processing. So they can use that API to constantly see the progress of the request. For example, I mean, hypothetical example. Uh, and finally, once the processing is complete, they can see that, okay, the request has been processed, etc., and then get the necessary response. Now, instead of consumer doing all this thing, we can take help of this callback processing, where consumer, while sending the request, can send a callback URL. So API gateway upon, sorry, not API gateway, the API upon invocation will immediately return an acknowledgement message to the consumer saying that request has been received, something like that. And then in the backend, it asynchronously, the resources, the API's resource will start processing the request. And when the response is ready to be sent back to the consumer, it can use that callback URL that has come along with the request to send the processed response back to the consumer. So this way we can make an API call asynchronous. Now it may not fully seem similar to Webhook API where like you are getting a constant stream, but rather it has to be requested by a consumer, and maybe after a while the consumer will get some uh, response back. Now, it may, as I said, the requirement of continuously send a stream of events may not be possible. At least I did not find a good way of doing that, but at least I figured that we can break from synchronous API to an asynchronous mode of processing. So if we are interested in configuring such callback processing for an incoming for an API or for that any API, we need to take care of few basic settings. So one such settings, that is the global settings, is called for callback processing, where so it is available under the administrator general setting. So here we can define a set of parameter to say like process all API callback requests. So basically this callback processor is required to keep track of the request and the response when the backend or the API's resource is ready to send the response. So if this parameter is checked, like process all API callback request, then wherever callback is implemented, those will be processed and allow HTTP access only. So this is to accept like whenever callback is required, the original API call must happen over HTTPS, and then only the callback can work if we select this parameter. And process only allowed IP's request, meaning we can accept callback request only from a set of trusted IPs. And when request is coming from those IPs, only then callback will be handled. Any other IPs will not be entertained. So these are like three parameters that we can set at the global level that will control the callback flow, whether or not callback will be handled or not. So the actual callback setting is residing inside of the API that is meant to do some kind of callback. So now this callback URL. So this is the general concept of callback. Which one did I configure for callback? Maybe I have not configured. Yeah. So in case of callback, as I said, like the request, the consumer must send a callback URL along with the request. Now, consumer can send that callback URL either in the request body or in the request header or in the request query parameter, or can be embedded in the payload. So we can define okay, before that, let me delete this load balancer. So we can already have an agreement with the consumer to say where this request will be or this callback URL will be sent to. And accordingly, we can configure API gateway to retrieve the callback URL using some predefined parameters. Okay. So if we want, so let's say this API will be able to handle the callback request. So we can have the request being sent to this API in this format. Just give me a minute. I'll set this request first. Give me a minute. I'll set this. So let's assume that and let's say client is going to send oh, my mistake. Sorry. It's already configured. I'm just looking at a wrong API. That's why I was okay. So for this callback thing, what I was trying to do is like a customer will send this so I was kind of trying to develop a ping or a heartbeat API that will be requested by a customer, and API gateway will start sending like let's say 20 heartbeat responses at certain interval of time. Um, after 2 or 3 minutes of the request being received. So for that purpose, I was trying to configure callback. So let me show you what configuration I have done. So the callback configuration is really simple. The trick is to parse the URL and then handle extract that URL to send the response back. Now, in callback mechanism, so this is like again a REST API. So we can define callback for a resource, saying like, okay, if the resource is requested via GET method or whatever is the resources method we want to use for callback. Accordingly, we can use this section to add a callback saying that send ping request will use this callback reference. Now, there are two ways of configuring and callback. Either we can use callback like specific for this method or for this resource, or we can globally create a callback logic and can reference to that. So either way, this even if I go, so if I want to globally create something, I mean the parameters are all same. So if I want to globally create something, I can create it from this component section. And as I said, like the customer is going to embed that callback URL in the request header. I mean, I assume that customer is going to send it in the request header. So I can define this parameter to indicate that API gateway should look into the request header parameter called client callback URL, and the callback URL should be extracted from there. So what happens at runtime is when the request comes to API gateway from the consumer with this callback URL, API gateway extracts this callback URL from that request header. And then when forwarding the request to the native or the backend resource or the backend service, it embeds that callback URL in the routing URL. Like we are always configuring a routing endpoint. We are always configuring an endpoint at the routing policy stage. So in that URL itself, it will embed this callback URL information as well as whatever method the customer or the client has exposed for this callback URL, that information will also be embedded. So in the configuration section, we just have to specify from which parameter the callback URL will be extracted. I have used header, so it can be request payload if it is coming in the payload. Maybe based on the message type XML or JSON, we can use XPath or JSON path to extract the information if it is coming as part of the query header. So these are, this is like yesterday I explained, these are all a variable framework. So based on the location where this parameter will be embedded, we can select either request.header or request.query or request.payload, then .json path, etc. So this is the callback setting I need to do at the API gateway layer. Now, although this is not fully working, but still I can show you at API when API is invoked with this callback URL, how API gateway handles the URL and forwards it to the backend. So let me quickly create this this REST project. So gateway API key is this one, my applications API key. I think for callback, yeah, this was the okay. Okay, so let's hit this service, and I have kept the website. Yeah, I mean, just was trying out something. So definitely it is not working fully. The service is not ready actually to, do the further processing. But my intent is to show that what I just said, like API gateway takes this this request. So this callback you also, if I look at this routing policy, so we'll see that the request has come, and this is the request URL that the client used to call this API, and they have forwarded this header element as the callback URL. And because I have enabled the callback processing for this particular resource and method, so now API gateway, when forwarding the request to the native service, it is embedding that particular callback with this callback directive, it is embedding that particular URL. So the URL is formed like this. The actual API native endpoint, then the application who is requesting the callback, then the invoke check APG service, the callback actual callback URL, and the method type. So what I should next do is this particular service, that is like whatever is my API gateways or the resource that I'm calling. So that particular service should return just a response saying request has been processed, and then it should start asynchronously processing the request, and from this whole URL parse the URL to extract the callback, the actual, separate the callback URL from this input, and identify the method type. And when it is ready to send the response back, should use that URL and method for calling the client service. So this is how it should work. So for that purpose, I started doing the development, but yeah, lots of things to do, so couldn't do it. So this is my main ping service, which is being called from the API. So this service actually should asynchronously handle the first parse this URL to separate the callback URL, and then start asynchronously handling this request. So when I say asynchronous, it can like call another service or invoke multiple threads of another services, or maybe publish it to an UM, and from there on, it's kind of like a true asynchronous processing can start. But this is one of the options if you want an API to work in an asynchronous mode. And yeah, as was your requirement to continuously keep listening for events, I'm not sure if that can be fulfilled, but at least the client can start this request, and we can develop the service in such a way that whenever like this, the trick is to develop that backend service that will be able to that has the knowledge that whenever there is an event or something, the callback URL must be called to send the event back to the consumer. So consumer may just call this API once, and then the backend service can be written in such a way that it keeps sending the events, further events using that callback URL. So maybe like we can explore on this option to see how we can enhance it further to meet the or replicate the exact webhook behavior. So yeah, I do not know if this was okay for you to understand, or it's mostly theoretical, but this way we can achieve this asynchronous processing. So anything on this callback processing or this webhook behavior?
Yes, it's helpful, but maybe there is a lot of questions related to this callback authentication, how we can authenticate the callback, because the client will not open his API to anyone to post any data. So it should be there is a kind of authentication mechanism or encryption mechanism or signing mechanism to the callback activity. Yes, it should be something like this. Yes, it should be something like this. So can he register his endpoints, then after the processing it should be received. But sometime the client, he interested in something but he didn't initiate the request. And he initiates the request, but he need to listen about this activity, like a news feeder or something like this. Maybe I thought I searched on them for the services. Maybe it can be achieved through the socket web.
WebSocket is another option, but
It is
yeah,
keep streaming. It keep streaming. I don't know how to
yes,
register to
yes.
this and keep this activity, but this is maybe what I need to achieve. But this is very good one. This callback also it is very good one. But I feel like there is maybe for this authentication mechanism maybe it is to be handled some way.
Okay, let's not get into that constant streaming requirement. So let's suppose that what you just said, like the callback URL, the application has implemented some kind of authentication when API gateway is invoking this callback URL or some services. So my idea is whichever service is now going to send the request, they should be capable of handling this authentication, because API, I can be wrong also, but I believe that API gateway will not be controlling that outgoing authentication to this callback URL. So whichever service is ready to send the response using the callback URL, I think something has to be done in that service level itself, not at the API gateways out of the box. But maybe I am wrong. We can always write some policy to attach this kind of outbound thing. But why I'm saying API gateway may not be able to do that, because this will become an asynchronous request. So I'm not sure if the same policies, like all these policies, can be applied on this callback. This, I mean, this the request that is going to this callback URL of the client. So that is why I'm slightly doubtful whether out of the box policies can be employed or not. But yeah, we have to explore on this. And about the WebSocket, yeah, it will. It's kind of that. I haven't worked with WebSockets, but I believe it is kind of that MQ listener notification kind of logic. So we have an option of creating WebSockets. So maybe that can be helpful for receiving this continuous packet information. So WebSocket APIs can be created from scratch, and once we need to provide this technical information like what is the WebSocket URL and if there are any parameters involved or any server or text level message, etc. Sorry, server or client level message that we need to embed. So based on that, we can configure this WebSocket API, and all the policies like authentication for incoming as well as outgoing authentication is still, we can still apply. So API behavior will remain the same, policies, applications, etc. Just that the specification of the API will be different because we are now using WebSocket protocol. So yeah, I mean, I cannot, do not have anything to create this WebSocket API, but yeah, WebSocket API probably will be a better option for your constant event streaming.
Yes.
Okay.
Okay. Thank you.
Okay. So last thing on this API gateway that I want to show is API mashup. So API mashup, I think on day one, I got utterly confused between API mashup and app mesh. So kind of juxtapose their description to one another. So API mashup, let me rephrase that. So app mesh, yeah, as we discussed on that day, thanks for correcting me. App mesh is something that is required for microservice based architecture to discover the microservice and basically put an API, create an API over the microservices and thereby connect microservices through those APIs to one another. And micro gateway can be used for this sideways communication. So that still remains the same. Now again. So mashup or mashups or API mashup is something like when we want to call two different APIs in sequence, we can achieve this mashup. So our normal use case, like we have these two APIs for retrieving the OAuth token, and then for use Hello World based on the incoming or the issued auth token. So instead of giving the consumer two different URLs or two different APIs for retrieval of token and actually call the API, what we can do is we can combine them and create an API mashup. So for that purpose, I have created this login and hello API, which takes the request for both token retrieval as well as the request for calling the hello world. And in the mashup, I have created what should be the sequence of calling this APIs. So if I have to, when I'm defining API mashup, I can select. So this login hello has one resource. Again, I'm taking help of the REST API. I'm sure on SOAP API, mashup is possible to develop on SOAP APIs as well. So just giving some idea on how we can do this. So this login hello API has a resource available. One is get and one is post. So we can decide whether for both HTTP methods or for a particular HTTP method, I will implement this mashup. So if I want to implement a mashup, what I can do is the start and end will come by default. So basically we are creating a flow logic here. So we can say like, what is my mashup step name? So get token is the first step of this. And then I can call the actual API that is already residing on the gateway to get the OAuth token or JWT token. So once I identify the API, so rest of the details, like they are pre-populated, like not pre-populated, at least they are suggested that what should be the method, the resource name, etc. And then I can add few more configuration to forward like all the incoming headers to the downstream API, then execute the outbound authentication policy as per the API configuration, as per this get OAuth token API configuration, etc. So this way we can define the different API steps. So we can always add another invoke. And let's say here I want to call call API. And here I want to call, let's say, for example, I want to call this calculator. Oh, calculator is created using SOAP. Okay, not possible. So we cannot combine a REST and SOAP. It has to be either REST or SOAP. So here we can see like what is the hello and method is post. Again, I can add the headers and all like this based on the requirements. Now, finally, I can join the dots by selecting, let's say, start and start from here. First call this get OAuth token, then select this one. And from here, call this hello world. And finally, hello world will be the last step. So it should call the end step. So this way we can create a mashup. Now, as I said, like I'll disable this. I have already created this mashup the same way I just showed. And what I'm going to do now is in my, I am invoking the API as is. So I'm going to invoke this login and hello API. And in my request, I am going to embed all the parameters that are needed to generate the OAuth token and finally the call for the hello world. So because now all these parameters are going to come in this one request. Additionally, like apart from defining each of these APIs, what I need to do is I need to create their payload type, like format their payload type. So I already know that my get OAuth token API requires these three inputs in the request payload. So I can use JSON path or XPath to extract the actual element from the incoming request payload. So you taking help of the variable framework, I can say like request.payload.json path has grant type has the grant type grant type value. Similarly, client ID and client secret can be extracted from the payload using this JSON path format. So likewise, even for the hello, I have to reformat this payload to say like name will come from the request. So if I am using a different attribute name here, the same has to be referred here in the JSON path expression to extract the parameter and to set it to the actual attribute of this hello API. So these are done all at the design time. So you will already get to know what will be the input message attributes, and based on that you can design all of them. So let's now try to call this hello world API, and I hope Tracer is enabled. Okay. So I should see that it is returning a proper response because these individual APIs can be executed. So from the routing, we can see like what is the mashup routing that took place. So the first mashup routing routed the incoming request to the get OAuth token, and this was the request body. And if I am, so this is the configuration. So if I have, I think, API request, yeah. From here, we can see the actual incoming request, and oh, it does not show the individual request, or probably it shows if I increase the API gateway's log level. But the point is, from here, we can see where the request has gone to, and if there is an error coming from any of these mashup APIs, that will be immediately seen, and we can fix those errors. So this way, we can save consumer effort to, instead of calling two different APIs, they can now call one API, pass all the necessary variables, and we can adjust these variables by, we can call a number of APIs to meet the requirement and adjust their inputs by extracting the variables from the actual request. So this was a simple request. So I mean, I'm not too sure how effective this mashup will be in case the request, I mean, one of the APIs has, let's say, hundreds of request fields. So how easy it will be to, create this payload dynamically. So of course, everything has pros and cons. So, but if for simple API requirements, we can always create mashup this way and can save consumer effort to call two different APIs. Now, one word of caution that when we are defining API mashup, so we are so any policy that were applied into the on this individual APIs, they will be ignored. And is it that they will be ignored, or which one? Okay, I actually forgot which one is ignored. Let me see. So yeah, I'll have to go back to the product document. It says it just says that if we are including mashups this way, so yeah, okay, now I remember. So the individual API, so the my get OAuth token or Hello World API may have some policies implemented to do some response processing, etc. So those will be ignored, and similar policy or formatting, request formatting, etc. we can configure at this mashup stage. So we can, like if a transformation of the request is required using a flow service, then we can configure it here itself. So we need to keep in mind that although when Hello World was actually implemented, we have done some policy configuration. So those policies will be ignored. If we are calling this API via mashup, those enforced policies will be ignored. And if we still want to use those policy features, something similar we have to configure at this mashup stage to take care of the particular requirement. So except for the routing, so get auth token is using a routing policy to route the request to an actual endpoint. Hello World is also. So except for those two routing policies, every other policy will be ignored. And if required, we can configure some of them here. Also, since this is like a normal API, so login and hello will be treated as a normal API. So whatever policy we want to enforce on this API, maybe log monitoring or error conditional error processing, etc., we can all do it on this API, and they will act according to the defined conditions. So this way we can create mashup. This was a very simple example. I believe there could be some complicated examples and requirements as well. But just wanted to give you an idea how mashups can be created. And yeah. Anywhere, any API. I mean, even if you have already developed some API, you can still add mashup logic into those API. You can still define mashups into that API. Now, in this mashup logic, I have sequentially invoked the API. We can also invoke this child APIs in, parallelly. So maybe after get OAuth retrieving the token, I can call Hello World, I can call calculator, multiple APIs I can call. So if we are doing parallel invocation of the child APIs, at the end, so we need something to aggregate all the responses. So in that case, there is an option available to use an aggregator. So we will, let's say it is like this from start. Also, Hello World is 2 blocks and 2 blocks. Then why? Okay, from start I cannot call, but from here I can, I think, can call several APIs. So somewhere, yeah. So we can do some parallel invocations also. And at the end, if we have to aggregate the result, we can use an aggregator, which will take all the responses and combine them by based on certain conditions, etc., like format the responses, etc. So this way we can either sequentially, ordinally invoke the APIs, or we can do them in parallel and then finally aggregate the response. So so the sequence is important, because whenever you are defining whatever sequence you are defining in the mashup window, in the same order will be followed at runtime. So be careful of the sequence. If you want to change something, you again have to go back to the drawing board and make the changes for the mashup to work in right API sequence. So that's all I wanted to show about this mashup. So with that, we are almost done with our API gateway related topics. So I have exactly half an hour left. So I will, yep.
Can I suppose this mashup?
Sorry.
Kind of what kind of license we need to have this feature inside the API gateway?
It is this advanced edition. There is no special licensing requirements for
Okay.
mashups.
So how we are able to enable it, because it is not actually shown inside our API gateway.
Is it? Because it should show by default, because I'm not using any special license. It is
Okay,
it comes
so
part
no,
part of the
let's let me log into my API gateway and to check together what is the exact license information you have inside your, or because you already it is local and it is not because what I have here, I have API policy application packages micro gateway, which is the only difference in the top menu. It is the app mesh. It is not appearing in my advanced gateway. And if I go to administrator, I go to license details, integration, license information, API gateway. Yes, the API gateway, it is a feature name. All of them, yes, except mashup. It is no.
For mashup, it is saying no, but for
No.
me, it is not even showing anything.
In the detail, I didn't check the configuration. Let me go to configuration. In the detail section, you go down to gateway. You will find it is yes, but in my side it is no. Then
It's not
go down.
appearing for me. Okay, keep going
Here,
down.
gateway, your mesh app mesh, it is yes. I don't have this one. It is saying no. And in the lesson information, there is nothing related to this mashup.
API mashup, yeah.
Yeah.
No, it
So
should
where
appear.
we are enabled.
Let me check one more thing. Oh, okay. I think. Oh, okay. I stand corrected. I think mashup is only possible for REST APIs, not for SOAP APIs. See, I have
But
opened
it
this
is in the top menu. You know, this is APIs, policies, applications, packages, micro gateway, app mesh. I don't have this.
No, app mesh is your license requirement. So please check what license you have. So maybe app
Where
mesh hasn't been. No,
okay, where I need to check the license information for this.
No, first of all, you can check your license configuration here on this. So your question is why app mesh is not appearing, is it?
Yes, if is there any additional setting I need to do
No,
to
you need
allow this,
not do.
because you
It is purely controlled by the license. So if you want app mesh to appear, please check with the sales team what kind of license deal have been made, if it is perpetual license or they have extracted some of the features and all, or is it all, it is also possible that AppMesh is, I don't think AppMesh is a beta feature. Maybe I'm using internal license, which is like gives me access to everything. That is why AppMesh is appearing. But I can suggest you check with your sales team to see what API gateway capabilities are bundled in the license. So it is mostly defined by that.
Maybe it is different. Maybe the difference in the version of the API. What is the differential? Is the version you already have?
I have
And-
10.11.
It should be the same, right? I think this. Where I can check this is this version information.
Version information.
11 product version 11.7. 10.7.
10.7, I doubt mashup is there. AppMesh is there. I need to check whether AppMesh is there in 10.7.
Actually, the name inside the license information, it exists, but it is not appearing. So
See,
maybe it is here, but
no,
it
the
is
license is not version dependent. License is given to a customer, and it covers all features. So if you move on to 10.15, the same license will be used. So because you are using API gateway, I wasn't aware that you are on 10.7. AppMesh is one of the features in 10.7 also, so should appear. Okay, API gateway Kubernetes. No, not this. So if not, then please check with your sales team.
There is a deployment configuration here, so maybe it is need a set of configuration to be applied.
See, it is when you are connecting with the AppMesh, then you need to configure this. I do not have any configurations on my API gateway. I have not done anything. So we can see no deployments found, but still it is appearing. So that's why I'm suggesting you, please check with your sales team to see what capabilities or features are included in the license. So the license license is saying AppMesh equal to no, so probably that is the reason. And if you want to use, then what sort of change you need to make? Maybe they will issue you another license if you have already taken perpetual licensing deal.
Okay.
But yeah, I cannot control, or there is no additional configuration required. And also one thing you can check, I'll check it later if I can find it. Maybe I'll confirm it back tomorrow. Whether at the time of installation, it is getting selected as a component. So I cannot run the installer now. So I'll do a check and I'll let you know tomorrow. If this is like a component that has to be separately selected at the time of installation, because I did typical installation of API gateway, maybe that is why it got included. So I can confirm, but if it is related to license, then sales team is your point of contact to discuss with them. Meanwhile, I'll check the installer, what it allows to install. But API mashup, that is available, but it is not available for the SOAP APIs. That is what I'm seeing from the behavior. So calculator is a SOAP API. I cannot enable API mashup. However, if I go to any of these REST APIs, I can see mashup feature available. Also, this is Hello World. Yeah, this is all SOAP APIs, so mashup is not available. So probably mashup is a feature only for REST APIs, not for SOAP APIs. So that answers why you cannot see mashup at the API layer. but app mesh is a completely different product. So need to check whether installer includes it or the license controls it. Okay.
Okay.
Okay, I will quickly give you I'll try to give you a demo on this Centra side, but may not be complete by the time we have left. So, so as I said, like Centra site, we can use it for our SOA driven development projects, or for establishing SOA governance and for creating service catalog, etc. So this is the look at the UI page of Centra site. So when you can install Centra site, and it will install two components. One is a Centra site registry repository. So basically that is the file-based storage system where all this metadata information, if we are attaching a specification for a SOAP UI or a Swagger file for a REST API, so all this can be stored inside that, or also like document references can also be stored. So that registry repository is like the storage. It is a file-based storage, and it is what is that term called? It is written using it's XML file-based storage. I'm forgetting the term. It uses a software or a tool called Tamino to extract the information and do all the processing, etc. So apart from that registry and repository, we have this web UI, and which is supported by an application server. So when we are restarting or starting Centra site, we have to start both the application server and the registry repository. So if the application server is not started, we won't get this UI. We won't be able to open this UI. Now, Centra site, as I said, like it can publish information back to so like we can define APIs here, and we can publish the API definition on the API gateway. In older version of API gateway Centra site combination, there was a restriction that any change that we are making on the API or on a policy, etc., cannot be synced back to Centra site. So those changes have to be manually incorporated in the Centra site. I'm not quite sure if still that restriction is there. And besides, these restrictions are for runtime policies, not for design time policies. So meaning like whatever policy we have implemented here for authentication or routing, etc., same thing can be implemented using Centra site and can published to API gateway. Additionally, on API gateway, we can configure more policies, but those policies cannot be moved back to the Centra site. So because of this restriction, nowadays we do not design any runtime policy on API or in Centra site. Rather, we leave them to API gateway to handle the API configuration, policy configuration, etc. So Centra site nowadays is purely used for maintaining a service catalog and governing the whole service life cycle. So any, not just service, anything. So if we have BPM processes, we can monitor or control the life cycle of the BPM process using Centra site, or we can control a service life cycle using Centra site. So whenever we are starting with Centra site, we need to take care of a few configurations. And again, these configurations will be given or or this configuration requirements will be given your business analysts and the integration architect or the enterprise architect, because Centrosite is not just meant for using or creating or maintaining web methods flow services like we can extend the use of Centrosite to basically create service catalog for all the application that an enterprise has. So maybe your core or legacy HR application has certain set of APIs and services. So we can create some meta information of those services here to view what exactly can be used if in case we have to build a solution, who is dependent on whom, etc. So for those purposes, we may need to create certain setups beforehand. We start creating the service catalog or start building the service catalog or process catalog, etc. So one thing we normally do is we create an organization. So we define an organization. So for example, Software AG is my organization. So any asset I create from now on will be tagged to this organization. So this helps me in categorizing which organization is owning a certain number of assets. So I can further drill down and say like inside Software AG, I can create a child organization saying like, okay, let's say Software AG. And by the way, Centrosite UI sometimes act in a weird way. You may not be able to scroll something, etc. So be careful while you are using this tool. So I was able to create, but okay. So before, yeah, child organization. So we can select that this is the parent and child organization. Yeah. And so I can say like Software AG professional services is one of the child organization, and it can be handled by. So now when I create create an asset, I can define whether the asset is belonging at the parent organization level or it is belonging to one of its children. So this way we can define like different. So for example, I can add HR department. I can add global HR or can add global IT or global deal department, etc., and can create their service offerings under those organizations. So this will give me like a nice view of when we try to view the assets. So it always starts with the organization, and then it goes like this. So my children organization is this, and then probably maybe I have created an asset underneath, etc. Likewise. So this child also can have another sub organization. So this way we can extract the information, and also like we can view who is owning which asset. So coming to the asset creation, so we can create a number of assets. So when I say asset creation, assets, these are like there are some predefined forms available which can be used to capture the asset information. So in order to see what are these the forms, so we can see that from where was that? Let me go back. Governance role, growth asset. Yeah, from asset types, we can see so there are these many predefined assets. So most of them will meet your requirement. So for example, if I want to create a service type asset, I may want to, so there are certain predefined attributes available for a service. So as I said, this is nothing but a form. So these are like the predefined attributes that are present for this asset. For this service type asset, I can add new attributes here. Let's say I want to add an attribute called business domain. And I can decide whether it will be like a classification or a list or a string type value, anything, or an enumeration. Enumeration is actually the list. So it can, and when the information is captured, I can also select one value or multiple values and can add, since it is an enumeration, so I can add values like HR, payroll, IT, something like that. Should be like this, HR. So at the time of service asset creation, when I want to capture this information, this will be shown to me as a drop down, and I can select what type of business domain the service asset is belonging to. So this way we can define the forms required to capture any asset information. We can modify this form to remove some of the already added attribute and can add new attributes, etc. Now, before, so this is like how we can capture the information. The next thing that we can take care of is the life cycle. So as I said, Centrosite's primary role is to control the life cycle of various assets. So let's say if I want to create a life cycle model for I can define life cycle model for all service type assets, something like this. So this is like a default life cycle model that is created by default, I mean created at the time of Centrosite installation. So if you notice this life cycle, it says like whenever, and so how to read this life cycle. So the green dot means it is the start point, and the red dot means that these are the endpoints. So now, so it's initial state and final state, and between the blue squares are like the different in between intermediate states. So how this default life cycle is working is that whenever you create an asset, a service type asset, this life cycle, if it is enabled, it will be applicable to all service type assets. So the moment you create an asset, it will initially be in the state of proposed. From there, you can configure approval. So this arrow type, if you expand this arrow, it will say what is the target state. So from proposed, I can move to either in design state or reject state or retired state. So these are the three possible targets. Now, if I want to move to InDesign state, so I can configure different policies for this movement. So I can most commonly I can configure like an approval policy where this maybe this will be sent to the business analyst, or maybe the business analyst is requesting for this service and it can go to the product owner or to the team lead to see whether this service is okay to build or not. So we can configure such approval workflow to say it is okay to go ahead with the service design, or we can say the service is already existing, hence request is rejected, so it will immediately go to rejected state. Or we can also say like this is the proposed service that is to be retired, hence we can retire the service. So from design, similarly, we can mention what should be the next stage. So mostly from design, we can go to development, from development to implementation, then in test to tested production. So this way we can control like which service is at which stage. Now, when we are defining this sort of life cycle, the only drawback is there has to be a person or a group of person who will continuously update the status of the asset. So the update of the status, I mean, this will only guide the present state, or only define what should be the present and what is the next future state of an asset. But if the actual state change has to be done manually by someone, or if we have configured approval workflows for this state change, then upon approval, immediately the state will be changed. But again, as it says, like approval, meaning someone has to sit through the approval mails and review the request, and then based on that, either approve or reject the request. So this is at a very high level how the life cycle, service life cycle can look like. So similar to the service life cycle, we have also like for processes, and if we want, we can create like for my API, what will be the life cycle. So we can define any number of life cycle here. There is no restriction as such. And we can tag like for which type of asset, like on which type of asset this life cycle will be implemented. So we can select applicable type. So for example, this is a service life cycle, hence the applicable type is service. And we can also decide whether or not this life cycle is active or inactive by, if I close this one. Yeah, so this button says I can either keep this cycle activated, or I can also deactivate it. Now, these are like the prerequisite steps before you start creating assets or start building your service catalog. So now, when you are done with all this configurations, prerequisite configurations, also, like another prerequisite configuration is defining taxonomy. So taxonomy is like if you want to achieve a complex hierarchy. For example, I have seen in banking APIs, so the bank has multiple domains, and let's say in the core banking domain there are different products. So like savings account, debit card, credit cards, etc. So each we can define like a complex hierarchy, and that will be used at the time of. So basically, these are like adding category to an already present attribute, and based on that, we can also use this taxonomy to either tag the asset or use this taxonomy in one of the asset attributes. So once you are done with all this, once you have all these requirements with you and you are implemented all this configurations, then you can start creating asset. So for creating an asset, we have to start by identifying what type of asset I want to create. So let's say I want to create a service type of asset, and let's say I want to create calculator service. So I can tag what is my organization. So if I am unsure that if it is belonging to PS or software AG, I can simply make it tag it to the parent organization. Or if wanted, I can tag it to my children organization, one of the children. So this way we can continue. So this is WSDL is available for this calculator API. So we can refer to this WSDL URL. So it will attach the specification to to this service. Now, this is what I was telling, that sometimes this API UI behaves in very odd manner. So I cannot scroll it down. So this is the only way of it. Yeah. So if I save calculator service type.
So it seems like all setting and all configuration, it should be done through manual interaction from a set of users related to set of groups or a permission site, the central site. So and there is no like as a discovery, it is not automated from the integration server or from the gateway. So how
it can be from integration server. So in integration server, if you are installing the I think designer has not designer or integration server itself, centrosite SOA governance. So if that is correctly installed, so from here you can from software AG, you can define the centrosite endpoint or UDDI registry. And then you can if you can configure centrosite UDDI registry using the username password. So let's say I want to publish this to UDDI registry. I think there is a publish option available somewhere. And this publish, and it says where I want to, as I'm saying, it is properly not configured in my designer. Otherwise, you will see centrosite as an option, and you can publish it to centrosite. Now, the question is why you want to publish it from here to centrosite, because centrosite should be the starting point of your development, not afterwards your development is done, now you are creating the catalog, because it is controlling your service life cycle. So any kind of service request, the specification should be first determined, approved, reviewed, and approved. Then only the design and development can start. So if you are deploying something back from designer to or integration server to centrosite, meaning you have already completed the service development. You are just keeping a track of the services. I'm not saying that is not important, but you will miss out on certain aspects, like when defining the service life cycle, or when defining the asset form, I can also enforce certain policies that a service name must be in this format. So if I'm now after development, if I'm publishing back to Centrosite, meaning I cannot implement those standards. It still can be done, but yeah, half of the purpose is defeated already. So yeah, of course we can do so. But to me, if we are starting with Centrosite, that should be the initial stage, and after that, the service development should happen. So basically, a service should go through the life cycle of the defined service, and should go through all the necessary approval process. So now the service immediately after creation, as per the life cycle state, stays in the proposed state. And if I'm like an approver, I can move it to any of this next state, because here no approval workflow is configured. So I can move it to the next state, and further next. So from design, it can go into one of these state. Now, okay, another thing, if you are publishing something back from integration server, you can only capture the metadata information of the service. So if you want to move it through its lifecycle state, you still need, either you have to configure approval process, as I said, and upon approval, automatically the service lifecycle will be changed, or someone has to come here and manually keep changing the life cycle state to keep track of its progress. So some amount of manual intervention is needed. You cannot completely have an automated Centrosite. Okay. So this way you can create service catalog, and also monitor the service lifecycle, and do governance on the services and the APIs, etc. So anything, I mean, even I have forgotten half of the things, so I could just remember these on top of my mind. So basically, this is normally done to create service catalog and all. Yep. Anything else you want to know about Centrosite?
No, no, thank you. But how the central side enforce controlling the naming of the services, and enforcing policy inside the integration server, or cross
No,
the development?
it cannot okay, so it cannot enforce a policy on the integration server. So it is purely on papers that says that my service name should be this. Only then my architect can approve the service. So when you start development, you define what should be. Maybe all the MOE services are starting, the packages are starting with MOE, then some business name. So these kind of checks, the validations has to be enforced in Centrosite when capturing the service requirement or the information. And the role of the approver is to see whether it is as per the standard. Also, we can assign some policies, like whenever I try to create an asset, like if I have the policy configured, at the time of adding this name, it can throw some error saying that this is not the right name of the service, or maybe downstream I can define what should be my package name, folder name, the service name, and there I can enforce such policies to say what naming convention should be followed. So doing that, I can only tell that this is what it should be like, but it still stays in Centra site. It doesn't go back to integration server to